So so we have y equals the absolute value. It was x plus 2 minus 3. Okay. So first of all, I have to identify this, and this is an absolute value. Once you read it and you say absolute value, you cannot write linear. Some of you wrote linear. It's not possible, right? Okay, so then immediately I will write the domain. The domain for such a function or equation is all real numbers, correct? Okay, so then I show that. Not too many of you show the domain in a chart. You just pick some numbers, but you didn't show the whole domain. I gave full credit, it was correct. But you have to show the entire domain, and then you pick some numbers, okay? Is that okay? So then I have, let's say, -4, -3, -2, -1, 0, 1, 2. It's more than enough. But especially for an absolute value function like this one, I would use all numbers in a, consecutive numbers. I will not try to skip. And let's see what we get. Do we already know the graph of an absolute value function? Is it a line? Is it a parabola? It must be a v function. So you have to make sure that it's a v function. It's mandatory. Okay, so when I plug in -4, -4 plus 2 is -2. The absolute value of -2 is 2. 2 minus 3 is -1. I plug in -3, I get 1. The absolute value, it's -1. The absolute value of -1 minus 3 is -2. Plug in -2, I get -3. Plug in -1, I get 1 minus 2. I plug in 0, I get 2 minus 3, which is -1. I plug in 1, I get 0. I plug in 2, I get 1. And by the way, my math lab gives you about 2 or 3 weeks of free access. So do not procrastinate, okay? Good, so then I will graph -4, -1, -3, -2, -2, -3, -3, -3, -2, -2, -3, -1, -2, 0, -1, 1, 0, and so on and so forth. I'm also asked to find the x and y intercept, so I'm going to plug in also -5, and let's see what happens. A -5 plus 2 is -3. The absolute value of negative is 3. 3 minus 3 is 0, and that's what I wanted. So this is the graph. And now I'm able to identify the range, which will be from -3 to infinity. And the x and y intercepts are clear. So x intercepts -5, 0, 1, 0, and the y intercept is 0, -1. Yes, any questions? You just have to plug it in. So which one would you like to check? So we make sure that this is... I'm sorry? Okay, -2. -2 plus 2 is 0. The absolute value of 0 is 0. 0 minus 3 is -3. Let's do one more. Let's say 1. 1 plus 2 is 3. The absolute value is 3. 3 minus 3 is 0. -4. -4 plus 2 is -2. The absolute value of -2 is 2. 2 minus 3 is -1. Better? Perfect. Other questions for me? Anything else? Yes, please.
I do -2, and then we do.
Oh, you have a yes. Go ahead. I'm sorry. Thank you.
-2 minus open parentheses 7x plus 5 equals 13 minus 3x.
Good. So I distribute -1, so it's 2 minus 7x minus 5 equals 13 minus 3x. I must combine like terms. Negative 7x minus 3 equals 13 minus 3x. Both sides are fully simplified. Since it's a linear equation, now I will move terms around. So I prefer the variable to be on the left-hand side. But that's me. Is it wrong if you have the variable on the right-hand side? No. It's just a habit, and I truly believe it's a good habit to have. Sometimes I will keep the variable on the right, but very rarely. So when I move negative 3x to the other side, it becomes positive. So negative 7x plus 3x is negative 4x. When I move negative 3 to the other side, it becomes positive. So 13 plus 3 is 16. So that's how we get the negative 4 as the final answer. Very good. Is that better? Perfect. So again, I highly, highly recommend, please read the notes, watch the videos. I still have 1, 2, 3, 4, 5, 6, 7 students who have never accessed Canvas. 7. So I'm not sure what's happening. I have a record and I can tell you exactly what you accessed and when and for how long. So I have, on the other hand, I have people who've been in Canvas. Okay, now somebody can get in Canvas and take a trip and then come back 3 days later, right? But I'm assuming that that's not what students will do, right? So I have somebody who was in Canvas for 5 hours, for 2 hours, for 2 hours, for 4 hours, and so on and so forth. 2 hours. So that shows me not necessarily just the dedication to this course, but you're trying. So I hope everyone will do that so we can move on as a team, okay? Please? Yes? Yes? Please. Okay. So anything else that you encountered? Other questions from... Always remember, looking and solving the examples in the book is a very good method. So look here. I just want to show you. So this is section 1.6 that I'm trying to finish up today. You have example 1. Have example 2. And it's solved step by step, and it tells you at each and every step what they do. Example 3, right here. Example 4, and so on and so forth. Example 5. Yes. Yes. Is it something from okay. Okay, what does it say? This is really okay. This formula is okay. And they want to use the formula to determine the shot's maximum distance. The maximum distance is okay. So in order, this is a quadratic function. It says it's coming from 1.5. Okay, so let me copy the equation. So what is it? Y equals
negative 0.01 x squared plus 0.4 x plus 6.1.
Okay, in order to determine, this is a quadratic equation. So I'm a little bit surprised that a question like that is in a 1.5. But in order to determine, this is part of the prerequisite course. So when I taught the previous course, the prerequisite for this class, which is for me what I taught is 012, we talk about the quadratic function, we graph the quadratic function, and we learn how to find the max or the min of a quadratic function. Now, I think that it's possible. I have to look at the problem one more time at the end of the class carefully, because I think they are only asking you to look at and enlarge the graph and just read from the graph. I'm not sure. I have to look. But anyway, regardless, in order to find the minimum or the maximum of a quadratic function, we have to determine negative b over 2a. Well, where this is a, this is b, and this is c. So this is the x-coordinate of the maximum, the x-coordinate of the vertex. So the maximum or the minimum, so vertex. In this case, it's a maximum because the leading coefficient is negative. When a is a negative number, the quadratic function has a maximum. When a is a positive number, the quadratic function has a minimum. And then the y-coordinate will be we plug in the function, this number, whatever we get. So in order to find the negative b over 2a, I'll have negative b is 0.4. 2 times a will be negative 0.02. When you divide these two numbers, and what I'd like to do is I'm multiplying top and bottom by 100. So it will be 40 over 2. So that's 20. So if this number is 20, in order to get this number, I have to plug in the function 20. And I'm going to use this chance and this opportunity to show you how to do this with a graphing calculator. So in y equals, if you have your calculators, let's put in this function, which is negative 0.01 x squared. This is the key for x, and this is the key for squared. And then plus 0.4x plus 0.4, and again the key for x, and then plus 6.1. So I have the function and I can evaluate it for anything I want as long as you go with me together second and table set. I would have to do this all the time because the computer will reset to the default when I turn it off. So, but you don't have to do it all the time. So once you do it, it's there. So I will have to scroll down and change the independent variable into ask mode. So scroll down and to the right for the independent variable only. So highlight ask and just press enter. So your viewing window should look like this. Now the calculator will allow you to plug in the numbers you want. So if you want to plug in 0, you'll get a number. If you want to plug in 2, you'll get another number. Which number do I want to plug in? Exactly. Thank you. It's the number that I determined. So so now again I have to read the problem one more time. If it's asking us when we get the maximum, the answer is 20. If I'm asked to find what is the maximum, then the maximum is 10.1. So it depends. Again, I have to read the problem one more time. And we can do that at the end if you want to look at it again. So this is the formula for the vertex. So this is 10.1. So f of 20 is, or y of 20 is 10.1. Okay?
Where did you get the 20 from?
40 divided by 2. I multiply the top and the bottom by 100. Or you can just plug in the calculator. So if you want to plug in the calculator, I hope that that's not the case. But 0.4 divided by 0.02, and the answer is 20. Very good. Anything else? Is there anything else we worked on? Anything else? I used to have a chair, but they took it.
I had one.
Yes. Yes. Thank you very much. So here we are asked to simplify this. So we have the square root of 9x squared times the square root of 81x. So we are asked to just simplify. Are we told anything about x? Are we told that x is a real number? Are we told that x is a positive number? Are we told anything about x? Very important. Yes or no? We're not told anything about x. No, I mean, are we told that x is any real number, or what do we assume? Because if x is positive, I will have to treat this in one way. If x is any real number, then I have to treat it in a different way. So the problem is not telling us anything? No. So in that case, I have to assume that it can be any real number. Okay, very good. So this is a product. I'm allowed to break a radical if it's a product underneath. The square root of 9 is 3, and the square root of x squared is the absolute value of x. So the square root of x squared is the absolute value of x if x can be any real number. Then here I have the square root of 81, which will be 9, multiplied by the square root of x. And of course, I will multiply these two, and I get 27, the absolute value of x, times the square root of x. Now you have to read the problem carefully one more time. If it says that x is positive, then there is no need for the absolute value bars. If it doesn't say anything, again, you have to read the question carefully. Is this okay?
Yeah.
That 81x.
I'm sorry?
Is that 81x?
Yes, the square root of 81x. Yep. Anything else? Is there anything else? Because I would like to go back to 1.6. We finished the quadratic equations, and we have other types of equations that we have to look at.
Is that the answer right there to 27?
27, the absolute value of x. I multiply 3 by 9. 27, the absolute value of x and the square root of x.
So that would be the answer.
Final. There's nothing else I can do here. But again, if the problem says x is positive, then there is no need for the absolute value. So again, we can look at the end of the class and see what the problem is telling us. So 1.6, other types of equations. Do you have anything else for me? Anything else once? Twice? Done. Okay, so number one type of equation is polynomial. And you can say, but wait a minute, what is a linear equation? I'll say, you're right, it's polynomial. And you can say, what about quadratic? You just finished quadratic. Isn't that polynomial? I'll say, yes. But we're talking about higher degree now than linear and quadratic. They're all polynomial so far. That's what and the rational that we looked at. Okay, so here's a problem for us, page 185. So problem 8 on 185. And here it is. 9y cubed plus 8 equals 4y plus 18y squared. What is the degree of this polynomial? Awesome. Thank you. Degree 3. How many solutions will I have to present?
3.
Awesome. 3. Degree 3, 3 solutions. Perfect. What do you think I'm going to do first?
Bring everything on the same side.
Awesome. That's the starting point. That's the starting point. And then I'm going to come back to this in a second. Absolutely. Now, when I move these two terms to the other side, what is left on the right? Right. If you omit the equal symbol and 0, you're not going to solve. You're going to change it into an expression. And that will not lead anywhere. Good. Now, please tell me how to write these terms. And this is the first very important key. So please dictate, how will I write? 9y cubed.
Plus 18y squared.
When I move a term that is positive from one side to the other side, very good, minus 18y squared.
Minus 4y
Awesome, and plus?
plus 6.
Good, good. So now I'm coming back to my strategy, and it says greatest common factor. Is there a common factor to all 4? No. Awesome. Is there a negative leading coefficient? No. Now I have to fit this into one category. Is it number 1, number 2, or number 3? Which one?
3.
Of course, it's a polynomial. It's not 2 terms. It's not 3 terms. It's more than 3 terms. Good. What is the only chance? That's it. Here's how I do it. And we've done this before. Please tell me what we factor out from the very first two.
1 squared.
Very good. What is left in parentheses?
1,
Perfect.
2, minus 2.
Minus 2. What do I have to have coming out from the other two? And of course, I cannot forget about the equal symbol and 0. Because if I don't get that, I can't continue. So what should I have in there? Of course. Only now I look. And let's see. I need a sign and I need a factor. Minus 4. Very good. So now what is the common factor?
1 minus 2.
Very good. What is left in parentheses? And notice again, the equal symbol and 0. Perfect. Thank you. So now we have an agreement on this. Here's our agreement. It was so sweet, I must have, no, it wasn't so sweet and I didn't eat it. So it's here. Okay, so what do I do with this? So how do I factor it? Very good. Awesome. So now can anyone give us those 3 solutions? From here. Very good. From here. Remember, I move -2 to the other side, it becomes positive, and I divide by 3. 2 over 3 indeed. And the other one, this is a positive 2, I move it to the other side, becomes negative. That's it. So these are polynomial equations.
Those are the 0 factors.
Say it again.
Those are the 0.
The zero product principle. Yes, awesome. Yes, very good. Well done. Okay, so now let's look at number 2, radical equations. Okay, so let's look at, let's say, number 12 on page 185. The square root of 20 minus 8x equals x. And if I ask you what type of equation this is, you'll say the equation is radical. Why? Because it has a square root. Very good. How do I eliminate the square root? What can I do? Right. I want to cube both sides. Will you allow me to cube both sides? How did you pick 2? Because it's a square root. What if I had the cube root? What would you have done? Of course. Now, I have to caution you on something here. This is not a safe procedure. It's the only one, but it's not a safe procedure. Why? Because the outcome of solving after I square both sides may or may not work in the original problem. The solutions that I get may or may not work in the original problem. So here's why. So if I have an equation and I add 5 to both sides, will the new equation have the same solutions with the original one?
Yes.
Of course. That is a legitimate operation. What if I subtract 5x from both sides? Will the new equation have the same solutions with the original one? It's a legitimate operation. What if I multiply both sides by 2? Will the solutions change? No, it's a legitimate operation. What if I divide both sides by 5? Will the solutions be affected? No, but if I square, that is not a legitimate operation. It's allowed, but I have to go back and check the solutions in the original problem, always. So when I square the left-hand side, what do I get? Very good. When I square the right-hand side, I get good. What type of equation is this now? It's no longer radical, but specifically which type?
Rewrite, make it quadratic.
It is quadratic, and I have to set it equal to 0. That's my only chance. So how do I do this?
A squared plus 8x
Very good.
plus minus 20,
Very good. Equals?
0.
Awesome. Remember we have 4 methods? If factoring works quickly, no cell phones please. If factoring works quickly, then I'll factor. If not, quadratic formula. So how do I do this?
8x plus 5, no, 10 x 2 minus
Good. So the options are x equals and x equals. Awesome? Awesome. Remember, they come with a big question mark. I have no clue if these work or not. So I have to go back. It's mandatory. Go back to the original problem. This is the original problem. That's where I plug them in. So I'm checking 2. So let's do this together. 8 times 2 is 16. 20 minus 16 is, the square root of 4 is?
2.
Check. I'm checking negative 10. Negative 8 times negative 10 is positive 80. 80 plus 20 is 100. Square root of 100 is 10. And the right-hand side is?
10.
So is 10 the same thing with negative 10? No. It doesn't work. The name of that is extraneous solution. This happens because we employed a principle that is not entirely legitimate, in the sense that we have to go back and check. There are many options here. Both of them may work. None of them may work, or just one. Okay, so always keep in mind when you raise both sides to a power, that is not 100%. It's the only way, but we have to go back and check. Okay, so let's look at equations with rational exponents. That's number 3. Rational exponent. Oops. Equations with rational exponents. And let's look at, let's say, 34 on the same page, 185. So x plus 5 raised to 3/2 equals 8. You can say, but this is a radical equation, and I would have to agree. Is there another way of writing x plus 5 raised to 3/2? The square root of
X plus 1
2. Exactly. So that's another way. You can change it into a radical if you want to. But let's say we don't. Let's say we don't. So how do I eliminate first the denominator, which is 2 here? What should I do to both sides? Square. I cannot just simply multiply the power. Right? So it's a square root. So I have to square both sides. So the left-hand side is x plus 5 to which power? 3 over 2 times 2 over 1. We have to multiply the exponents. 3 over 2 times 2 over 1 is 3. The right-hand side is 8 squared, which is very good. Now what? Remember, I squared both sides, which means I have to go back and check. So now what will be the next step? How do I eliminate this? The cube root, indeed. So the left-hand side is?
X plus 1.
Very good. And the right-hand side is?
4.
Awesome. What type of equation is this now? This is the simplest possible one. Linear, very good. What do I do to solve this linear equation? -1. I subtract 5 or move 5 to the other side. It comes with a question mark. I have no clue. So I have to plug it in back in the original problem. -1 plus 5 is 4. And it's raised to what power? Good. So let's do that with a calculator. Right, to illustrate that. Here it is. I did this problem an hour ago with the other class. So 4 raised to 3 halves. 4 raised to 3 halves is 8. So here's how we plugged it in. Plug it in. 4 caret in parentheses 3 divided by 2. Close the parenthesis and press enter. Any questions? Any questions from me? Okay. The next one is a little bit more sophisticated. The next type, a little bit more sophisticated. So that is my number 4. Equations. Quadratic. And you can say again, no, quadratic in form. What does that mean? It means definitely not quadratic. But equations that can be replaced by quadratic equations. Sounds interesting, I hope. Okay, so let's take a look at an example here. Let's say 44 on page 185. 4x to the 4th equals 13x squared minus 9. So let's look at this and say, First I'm going to ask you what? What is the...
Degree.
Awesome. Exactly. I'm going to ask you what is the degree, because that will tell us exactly how many solutions we are looking for. So what is the degree?
4.
We are looking for 4 solutions. What should I do? Awesome. Good. So what do I write? I have 4x to the 4th.
Minus 13x plus 9.
If I omit this, I'm not saying you would. I'm saying myself, if I omit equal symbol and 0, I will never solve for anything. I will change it into an expression and I lose the equation somewhere. Very good. So now, I don't know how to factor this. It has degree 4. I know how to factor quadratics. And I'm looking at this and I see that this, if I use a substitution or I replace x squared, let's say, give me a letter, not x.
B.
B. So if I say let b be x squared, only if this can be replaced by,
B cubed.
if it's b cubed, then this will not be quadratic in form, and I will not know how to solve it. So this is indeed b squared, because when I square x squared, what do I get? Copy the base, what happens with the exponents? We just did that a few minutes ago. Copy the base, we multiply the exponents, right? So I have to multiply, so this is 4. So then, can anyone dictate the new equation?
B squared minus 13 B.
two options here. This is quadratic. And you can say, wait a minute, you changed the equation from x to b. True. I'll go back to x in a minute. So now here we have two options. Either we try to factor, it's not going to take this fast, or use the quadratic formula to get b. It's up to you. Not completing the square, of course, and definitely not taking square roots. I can't. So which one would you like to apply? Okay, so let's do the quadratic formula. So if that's the case, then I have b equals, can anyone dictate? Negative b, which is 13, plus or minus the square root of, yes, which is 169, minus 4 times 4, which is 16, and times 9, over 2 times a, which is 8. So with the graphing calculator, quickly, I can perform that operation, see what I get. 169 minus 16 times 9. And if it's a perfect square, which I hope it is, and yes, it's 25, then I know the answer for the square root would be, yes. So then b equals 13 plus or minus 5 divided by 8. So there are two possibilities for b. Can anyone give us those two possibilities for b? So 13 plus 5 is 18. So b will be 18 divided by 8, and I simplify by 2. So b will be then 9 over 4. And the other option for b will be 13 minus 5, which is 8 over 8, which is 1. Awesome. Are we done? No. I have to go back to the substitution. So I have now two equations I'm looking at. I'm looking at the equation b equals 9 over 4, and I'm looking at the equation b equals 1. Are you with me? Any questions?
Why would you just leave it at x?
Because I can factor x to the fourth. I don't know how. Good. So now this equation is definitely what equation? What did we denote by b? That's it. And what is this equation? Now I'm back to quadratics, and I know how to solve these because I know 4 methods, and there is one in particular that works here very fast. Which one? Taking square roots. Very good. Remember how many solutions we have to get? Very good, 4. So please give me what I get here. Nope. Careful. I will not get 4 solutions if you only say 3 halves. Very good. When we take the square root, remember it's a quadratic. We have to have 2 solutions, right? Good. Okay, what about the other one? Have we gotten 4 solutions? That's it. Very good. Last type is absolute value equations. I shouldn't say the last, because it's also literal equations. So absolute value. Okay. There are 2 possibilities when it comes to absolute value inequalities, but only one with absolute value equations. So I'm going to just give a very simple example. The absolute value of x equals 3. If you give me this equation and you ask me to solve, here is what goes through my mind. What am I really asked to do here? I'm asked to find numbers. Absolute value is the distance, right, between the number and 0. I'm asked to find these numbers whose distance from 0 is exactly 3 units. How many numbers are found exactly 3 units away from 0? 2 numbers, and they are
Negative and positive 3.
Negative 3 and positive 3. Let's check. Is the absolute value of negative 3, 3? Is the absolute value of 3, 3? That's it. Now I'm going to choose a problem, and you'll say, wait a minute, this doesn't really look like what you're just talking about. So for example, let's say problem 72 on page 186. It's not going to look like what we just looked at. However, we can clean it up, and it will look like what we just looked at a minute ago. What do you think we have to do first? By the way, if you try to treat the absolute value bars like a grouping symbol, please don't. You cannot touch this. This is under lockdown. Nothing. You cannot put anything in, you cannot take anything out, you cannot multiply, you cannot simplify, you cannot break the absolute value. Untouchable. So what can I still do in this equation to clean it up?
4 and 7.
Yes, but what step is first and what step is next?
Subtract 7.
Of course, I have to subtract 7 first. Okay, I subtracted 7. What will be the next step?
Divide by 4.
That's it. Now I'm back here. And you could say, but wait a minute, it still doesn't look like that. Yes, it does. So let's think together. I'm asked to find numbers whose distance from 0 is 3/4. So what should I have in here? What can this expression equal so that the absolute value of it is 3/4? Or, that's it. Awesome. Thank you. So here there are two options. 1 minus 3/4 x equals 3/4, and 1 minus 3/4 x equals negative 3/4. We are just mimicking the simple example. It's just that inside I have a much more sophisticated expression, but it's the same thing. Very good. Now let's decide what to do. How do I solve the equation 1 minus 3/4 x equals 3/4? What do I need to do first?
Move the 1.
Yes, we can move the 1, or we can eliminate fractions. It's up to you. I'm fine with either one. Let's multiply both sides by 4. Or 4/1. This will be multiplied by 4, but here I want to multiply it by 4/1, and here I want to multiply it by 4/1, so I can see what I simplify and what is left. So what is left?